Hi everyone, my name is Andrew.
I'm Anj.
I'm Anna.
I'm Anvi.
I'm Julia.
My name is Garima.
My name is Ramaisa.
My name is Clarice, and on behalf of Touch Tomorrow and the entire MGM team, we'd just like to say,
Welcome to the Massachusetts Math Modeling Jam.
Our team has worked together to create and run the Massachusetts Math Modeling Jam, a celebration of math modeling in the real world. This event was made possible thanks to the support of WPI, Touch Tomorrow, and our team here at the Massachusetts Academy of Math and Science. We hope you're just as excited as we are, and we can't wait to work with you this week.
So, what is math modeling? How does it work? Put it simply, math modeling looks at trends and patterns in real-world data in order to come up with solutions to some of the most pressing problems our world faces today. These problems come from all sorts of fields, from technology to physics and business, to fashion to construction. You can find math modeling everywhere.
and believe it or not, math modeling is already a huge part of our world.
For example, many areas of physics, like fluid dynamics and astrophysics, rely heavily on math modeling and simulations in order to model complex phenomena, all the way from water ripples to forces to black holes.
Video games such as Mario Kart and Legend of Zelda rely on mathematical models to have characters move and interact with various mediums realistically.
Math modeling is also used in epidemiology to predict how diseases spread and model the various outcomes to potential scenarios.
Businesses use math modeling to consolidate factors such as cost and traffic in order to find the best spot to open new franchises.
And on top of all that, there's a really high demand for math modelers everywhere. For example, Joy Buolamwini is a computer scientist who founded the Algorithmic Justice League in order to bring awareness to systemic racial and gender bias presented in various forms of AI. She looks at the ethical ramifications of math modeling. Elon Musk is an engineer, entrepreneur, and co-founder of PayPal, SpaceX, Neuralink, Tesla, and many more companies. Every day, he's using various math modeling concepts to come up with new ideas and manage all his corporations.
Companies like Pfizer, Snapchat, Instagram, Facebook, and MathWorks can also use math modeling to develop marketing strategies. They've made some fancy models that keep track of consumer preferences, tailoring content to be enjoyable and understandable to any user. Math modeling isn't always as clear as solving equations and crunching numbers. Sometimes it's hidden in plain sight.
Starting tomorrow, we'll be releasing 3 new videos here on Touch Tomorrow's website detailing a unique STEM field along with a daily question. You'll have from then until 10 a.m. the next day to submit your solution to the problem. That'll give you 24 hours to watch our presentation, review our helpful resources, and take a shot at the problem. Some problems might appeal to you more than others, so not to worry. To participate, all you have to do is submit solutions to any or all of the daily questions you choose before the deadline. This shouldn't take too much time out of your day, because we aren't expecting solutions longer than one double-spaced page.
Each answer we receive will be graded by our judges in categories like creativity, the explanation quality, and real-world applicability using the rubric you can find on our website. You can review our solution template, rubric, resources, and daily questions on our website, mmmjam.github.io. 3 solutions from every day will be recognized at our live award ceremony on June 12th. Tune in to celebrate everyone's hard work. Here, we just want to remind you, there is no right answer. 3 daily awards won't necessarily go to the solutions that have the most complex equations or the highest accuracies. We want you to learn, experiment, and above all, have fun.
Trust us when we say that math modeling might not be as mysterious as you think it is. Most of us have never done math modeling before our junior year of high school, but we're able to pick it up pretty quickly after learning these 6 steps.
Let's look at each of these in the context of a real-world problem. Say that you're driving home from school in a car low on gas. You could always go to the gas station that comes up ahead and considerably closer than other stations. But the gas here is always pretty high in price. You remember that a friend told you about another station several miles off your typical route where gas is a lot cheaper. The dilemma you have is shown in this diagram to the right. What would a math modeler do to solve this problem?
The first thing would probably be to identify and specify the problem at hand. In this case, how can we determine the best gas station to go to?
We then take a bird's eye view of our situation to make assumptions. Assumptions are reasonable statements we assume are true and build our model. So in our case, we could assume that we have enough gas to go to either station, Otherwise, this wouldn't really be much of a problem in the first place. We can also assume that the cost depends on the price of gas per gallon. Some important factors we could consider are the distance to each station, the traffic we get into, our tank capacity, how much time we have before we need to go home, and so on. We'll call each of these our variables, important values we need to track, but are bound to change in different scenarios. This makes the best gas station one that is low cost and quick to reach. So after some thinking, we'll define a successful model as one that is the cheapest overall or most cost effective.
Once all the data, assumptions, factors, and measurements have been gathered, we can build an equation and actually do the math. Here you can see all the materials we'll use to build our model, a picture of our problem, and variables we want to include.
By using P total to represent the total price of accessing a gas station, MPG for the mileage of our car, G bought to represent the gallons of gas we bought, and other variables, we can compare P total for different routes and compare them in our model. Our model looks at which gas station would cost the least in terms of cost of gas and time lost. We'll visualize this in tables or graphs.
With our new math model, we can figure out which station to go to and how to get to another location after reaching the gas station by plugging in relevant data for the equation in our model, which is shown on the screen. By visualizing our model in graphs by plotting P total for each gas station, we'll notice that gas station C has the lowest P total, which is shown in green on the graph, and thus is the best option for scenario 1.
If we look at scenario 2, you can see that gas station C has the lowest P total or total price. This makes gas station C the most economical for both situations we're trying to solve.
Iteration, refinement, and improvements play a huge role in extending math models beyond one specific situation. So this means that we'll review our equation, try different data sets to see what went well, what could be improved, and what we learned about driving in gas stations overall. We've realized now that our model works pretty well just considering the distances between different routes. But there's a lot of things that could affect our decision to go to a gas station, including our schedule, any car problems, proximity to Dunkin' Donuts or Starbucks, etc., that we might want our equation to include in future iterations.
Now, we can report our findings and present our model with friends, family, and even coworkers to use. When presenting your model, it's helpful to describe the process you used, where your idea came from, and make it as easy as possible for other people to use your model. For us, we wrote a paper to present, which is on our website, but it would be more useful for people if we built a net price calculator or something like that.
These 6 steps will be very similar to the ones you'll use at MJAM. Never be afraid to revisit your steps as you see fit, or ask for help if you need it. Just like the real world, math modeling is supposed to be dynamic, useful, and fun. You can also report your results through presentations, conferences, or even in random conversations with your friend. For the MJAM, you'll be reporting your results through writing in a Google form. And that's it. Tune in for our first of 3 daily questions tomorrow. Check out our website at mjam.github.io for more information and resources, as well as submission links for each problem. If you have any questions or feedback, email us at mjam.team@gmail.com. Also note that you can find all the citations we use in our presentations on our website. Good luck, have fun, and see you tomorrow!